Hello, Morphlings, and welcome to episode 3 of our startup journey. Last week, our CEO, Paul, discussed the advantages of aligning the fibers along the axis of stress. I am Ferdy, and I'm here to discuss the algorithms and techniques that helped us in the automation of our FreeForm Winding Technology. It's about to get geeky. You've been warned. Let's go! As you may remember, we have a machine that can deposit fiber material. However, that machine needs instructions in the form of GCode, which is one of the most standard way of control for most 3D printers and CNC machines. A sample line of GCode is something like this. This command indicates that the machine move at these coordinates, which may be relative or absolute, and extrude this amount of material. In most 3D printers nowadays, the G-code for your entire object can be automatically generated through the slicer program. As you can see, you have the G-code, and you can see that the plastic material will be placed on your object layer by layer. However, Houston, we have a problem. As you can see here, the material will be placed in a horizontal direction and not in the direction of the longitudinal which we want. This will be a problem because, as described last episode, the strength of a composite material is highly dependent on the orientation of its fiber. This is what we are trying to solve. Unlike in 3D printing, we don't need to generate the path for every volume of the object. We only need to ensure that the fiber is laid along the longitudinal direction, and the next parts of the process will be able to consolidate this material. And that will form our target object. So now, we need to transform this 3D object into this path. Like everything, we can do this manually. But where is the fun in that? So let's try to automate the process. First, we project our 3D object into a 2D image for easier analysis. Once we have this image, we use a thinning algorithm to generate a possible path for our target objects. From these points, we can generate key points from the intersection of the lines and use that as nodes in our graph. Then, we only need to traverse the edges, and now we know our path. Now that we have this information, how can we translate it to the useful G-code our machine needs? We simply project our 2D points to our 3D mesh. This is done by finding an intersection between a vector and a plane. From these 3D points, we can simply generate the G-code using the movements that follow the path traversal of our graph. And the good thing about this method, as opposed to manually generating each path, is that we can produce multiple possible paths. And from these multiple paths, we can choose which path can be a good candidate for a stronger composite part. And this is just the start. There are still many improvements that can be made, and at Morph, we believe in continued research and development to further improve our process to deliver the products of the future. Watch out!